All right, so this is 7.2, hypothesis testing for the mean with larger samples. So section 1 was smaller samples. These are going to be for large samples. So you guys can take notes on your PowerPoint like you normally do, or by hand, whatever works for you. But I would just follow along and make sure you get all of the information down. So it says using p-values to make decisions. In chapter 5, if n was 30, the sample mean is normal. In 7.1, what we just did, you make a conclusion in a hypothesis test by using the p-value for the same stat such as the sample mean. So we said if the null is true, that means a p-value of a hypothesis test is the probability of obtaining an extreme sample statistic. So we came up with our decision rule based off of the p-value. And our p-value is going to be compared to that Jesus fish or the level of significance. So if your p is less than or equal to your level of significance, you're going to reject your h sub o. If your p is greater than your level of significance, you're going to fail to reject your h sub o. So let's look at the first example. This is on page 371. The p-value for a hypothesis test is p equals 0.0347. What is your decision if 1, your level of significance is 0.01, and 2, your level of significance is 0.05? Well, you're always comparing it to the p first. So in this case, my p is 0.0347. That is bigger than my level of significance. So my decision would be to fail to reject my h sub o. In the second case, when my level of significance is 0.05, my p is smaller than, so based off of the decision rule, I would reject whatever the h sub o is. So how do we find the p-value for the hypothesis test? So after figuring out the hypothesis test standardized test stat and the test stat's corresponding area, you're going to do one of the following to find the p-value. So if you're in the left tail, the p is exactly the area in the left. So that means my graph looks like this, and you take the area as is. For a right-tailed test, your p is the area in the right, which we know to find the area in the right, you have to do 1 minus. And then the last, for a two-tailed test, your p is 2 times the area in the left, since you have 2 tails. Okay, so similar to left, right, and two-tailed rules already, left tail is just area as is, right tail you would have to do 1 minus, and two-tailed you would have to do 2 times the area in the left. So second example is on page 372. It says find the p-value for a left-tailed test with a test stat of z equals negative 1.71. Decide whether to reject h sub o if the level of significance is 0.05. So first of all, it's left-tailed. So I'm looking like this, which means my p is just going to be the area. I know that my area is when I look at that back chart. I'm looking at the z-score chart, which I'll turn there now. In your book, that's on page A16. I'm going to go to negative 1.71, and I find it to be 0.0436. So if I compare my P to my level of significance, my level of significance is bigger, and based off of my rule then, since it's bigger, I would decide to reject the H sub O. Let's look at the third one. The third one is also on page 372. Okay. In this case, it says find the p-value for a two-tailed test with a test stat of 1.64. And it says that it's two-tailed. Okay, well 1.64 is actually going to be for my right tail, so I have to be careful with that. We could adjust what we have up here to just area in whatever tail is given. It's probably a little bit better. If it's negative, it's going to be the left tail, which I'll just take it as is. If it's positive, that means it's the right tail, and I'll have to do 1 minus, so we can look out for that. Probably better to define it that way instead. So it gives me my test stat of 1.64. It asks me what am I going to do if my level of significance is 0.10. So since it gives me the right, I'm going to have to do 1 minus what I find in the chart. So again, I'll go back to that page A16, and I will look at 1.64, 0.9495. Okay, so I will subtract first, and then I'm going to have to multiply it by 2 because it is two-tailed. So 1 minus 0.9495, multiply that by 2. I find my P to be 0.101. Okay, so if I compare my P to my level of significance, my P is greater. So based off of my decision rule, since my P is greater, I am going to fail to reject H sub O. Okay, so what if we have a z-test? This is going to be used in populations for which the sampling distributions of sample means is normal. Remember, anytime we have the option or the ability, we would rather use something that is normal than something that is not. We can use the z-test to find the standardized value for your test stat. Most of the time our test stat is always our sample mean. So we could find it this way. Our z is the sample mean minus the hypothesized mean divided by standard deviation over the square root of n, which we've had this before. So z-test for the mean is going to be a stat test for the population mean. It can be used with when the population is normal or is known, or it can be used if the population is at least 30. So your problems either have to say it's normal or your n is bigger than or equal to 30. Then you can use the z-test. If not, you cannot use the z-test. So you could say your z, if you wanted to write it in words, is your sample mean minus your hypothesized mean all over your standard error, which we wrote it out in symbols before. X bar minus the mean over standard deviation over the square root of n. It's the same thing, one's in words and one's in symbols. So let's look at example 4 on page 374. Homeowners claim that the mean speed of autos traveling on their street is greater than the speed limit of 35 miles per hour. A random sample of 100 automobiles has a mean speed of 36 miles per hour and a standard deviation of 4. Is there enough evidence to support the claim at a level of significance of 0.05? So let's write down all of the information first. I know I'm going to need my H sub O and my H sub A. And it says I'm talking about mean speeds, so I'll put mean here for both things. I know that H sub O can have an equal to, H sub A cannot. It says the homeowners claim that the mean speed is greater than 35, not equal to or more than, it just says greater than. So that's going to be here. This is my claim, which means the opposite for H sub O. A random sample of 100, that gives me my N is 100, have a mean of 36, so my sample mean here would be 36, and a standard deviation, oh, my pen's dying, standard deviation of 4. So we're going to plug that into our z-score first, figure out the tail and our p-value, and then see if we can reject it or accept it. So let's plug this information into our z equation. Okay, so I would have x bar minus the mean they give me over 4 over the square root of 100. So I'll plug that into my equation. I get 2.5. So I'm going to have to find my p-value, but first I should figure out if I'm left, right, or two-tailed. Remember, we're always looking at the H sub O, and in this case the H sub O is pointing to the left, which means it's actually right-tailed. Also, I noticed that it's positive, so I should assume that it's going to be right-tailed. So my P is going to be 1 minus what I find on the chart. So I go back to that Z chart in the back of the book, A16. I'm looking at 2.5. And I see 0.9938. So solve for your p-value. Gives me a level of significance in the problem of 0.05. So I have to compare the p and my level of significance. Well, 0.5 is bigger than 0.0062. Therefore, since my level of significance is bigger, I'm actually rejecting my H sub O. And in this case, if you're rejecting the H sub O, that means you're supporting the claim. So they were correct in assuming that. So let's look at number 5. Page 375. Okay, one of your distributors reports an average of 150 sales per day. So I'm going to go ahead and write this out as I read it. We're talking about average or mean. I know H sub O is the only one that can have an equal to. And it says an average sale of 150 per day, so that would be equals 150. This is my claim. Opposite would be my H sub A. Since I see equal to or not equal to, I know I have a two-tailed test. So rest of the information, you suspect that the average is not accurate, so you randomly select 35 days. So I can do this because it's bigger than 30, and determine the number of sales each day. The sample mean is 143 with a standard deviation of 15, and I'm comparing it to my level of significance of 0.01. So let's plug this into our z-score and then we can go from there. My z is going to be my sample mean, 143, minus my given mean, 150, over the standard deviation for the square root of n. So I'll plug that in. And I get negative 2.76. Okay, that's going to be my left. So my p-value is just going to be 2 times whatever I find, since that's my left tail. So I'm going back to my z-score chart, and I'm going to look at negative 2.76, which is 0.0029. So if I compare my p and this, I see that my level of significance is bigger. So since my level of significance is bigger based off of my p-value, I reject h sub o. And if I reject h sub o, in this case, I am not supporting the claim because I just threw it out. So they don't have enough evidence to support that claim. Whoops. Okay, so now we get into something called rejection regions and critical values. So another method to determine whether or not to reject the null is to determine if the sample stat falls in some range of values. We call this range the rejection region or the critical region. It's the range of values for which the null is not probable, so therefore we reject it. The critical value, z sub 0, separates the rejection region from the non-rejection region. So let's look at this. We have some guidelines. These are also on page 376, but first you're going to specify the level of significance. Decide which tail. So again, we're looking at left, right, or 2. Find your z sub 0. So z-score with an area of your level of significance, or if it's right tail, it's going to be 1 minus your level of significance, or if it's two-tailed, it's going to be 1/2 this, and 1 minus 1/2 your level of significance, and then you're going to sketch the graph and draw a vertical line at each z and shade the rejection region. So let's plug in some numbers and it'll make more sense. But these 3 rules are the same ones we've had even in last chapter, but now we're just plugging in our level of significance. So we're not going to have the same sort of information like we did on the other 5 examples. These will be a little bit different. So number 7 is on page 377. It says find the critical value and rejection region for a left-tailed test with a level of significance of 0.1. So first of all, it says left-tailed. So I think it's easiest if you draw it out first, like this, left-tailed. So I know my z sub 0 is going to be somewhere over here. Well, if this is left-tailed, then I know my area is the same as my level of significance. So I can look back, and I'm going to look for something with an area of 0.1, which means I'm looking at my chart, and now I'm looking in the middle, and I'm working my way out because it's asking me for a z-score. So page A16 again, I'm going to find 0.1 in the middle of my chart, which I see is at negative 1.28. So that shaded region then is my rejection region, and anything that would fall in that space I would automatically have to throw out. So let's try another one. Same page. Find the critical values and rejection region for a two-tailed test with a level of significance of 0.08. So, two-tailed test, I'm going to draw it out first, like this. So I'm going to have a negative and a positive. Remember, they're the same, they're just different signs. So I know that this is 1/2, and this is going to be 1 minus 1/2. So I'll plug in 1/2 of 0.08, which gives me 0.04 here. This would be 0.96. Okay, so I'm going to look for my z sub 0. I'll look at, you can really do either one, but I'll do 0.04. So again, looking at A16, I'm looking in the middle of the chart at 0.04. And I see that's at negative 1.75, which means the next one is going to have to be 1.75. And all they're asking for you to do is shade those rejection regions, and we did. So how are you going to use these? Well, we have a decision rule for the rejection region. If the standardized test stat is in the rejection region, you reject it. If not, you fail to reject it. Pretty simple. So if it's in that shaded area, you throw it out. So if I'm looking at a left-tailed test, this would be where I reject. If I'm looking at a right-tailed test, this is where I reject. If I'm looking at two-tail, anything in here or in here would be where I reject. Pretty simple. Okay, page 379. The CEO of the company claims that the mean workday of the company's mechanical engineers is less than 8.5 hours. So I'm going to start off with H sub O, H sub A. I'm talking about the mean. I know H sub O is the only one that can have equal to. I'm comparing it to 8.5 in both cases. The claim is that it's less than 8.5. So this would be my claim. So this would be opposite. Okay, so looking at my H sub A, I see it's pointing to the left, so it's going to be left-tailed here. A random sample of 35. Okay, so I can use the z-score. Has a mean of 8.2 with a standard deviation of 0.5. We're comparing it to 0.01. And they want me to use this rejection region. So if I'm looking at it, my rejection region, since it's to the left, should be anything where this is my area. So my z sub 0 in this case would be where I have that area. So I'll look back in the back of the book. I'm looking for 0.01, and I see that's at negative 2.33. So now I need to plug all of the other information into the z-score equation and see if it is in my rejection region or not. So plug this information into z. I would get x bar minus my mean over 0.5 divided by the square root of n. So I'm going to plug that into my equation. Okay, so now let's compare this over here. Well, that's going to be on this side. Negative 3.55 is smaller, so it is in that rejection region. Therefore, I'm going to reject my H sub O. If I reject my H sub O, I just supported the claim because it was in my rejection region. So a little bit different than the p-value test, you can just look at your rejection region. So let's try one more before we're done. This is page 380. Using the information and results in example 10, determine whether there is enough evidence to reject the claim that the mean cost of raising a child from birth to age 2 by a husband and wife family in the U.S. is $13,120. Use the level of significance of 0.01. So if we look here, it says in example 10, H sub O is here, and that's the claim. Okay, so it gives me all of my information in example 10. It's already solved everything out for me. And since it's equal to and not equal to, I know that it's actually a two-tailed test. Okay, so that's good. But this time it wants me to give a level of significance of 0.01. So a little bit different. When they plug in all of their information, they get their z-score is negative 2.5, and we just need to find our area here to then solve. So I need to look at 1/2, 0.01. And then I'm going to look in the back of the book for that area. 0.005. Again, I'm looking in the middle because I'm looking for my z-score. I see negative 2.585. So that means I'm comparing to negative 2.585 and 2.585. And where does this fall? Well, this falls somewhere in the middle here. Therefore, we do not, whoops, but if you didn't reject the H sub O, are you supporting the claim? Not necessarily, because you didn't throw out the contrary. So you're not necessarily supporting the claim. You could say not enough evidence to support the claim. Because remember, in order to support something, it means it has to be the only thing left. So even though I didn't throw it out, I don't have enough to support it. Okay, so here's your assignment. It is on schoolwork, it's on RenWeb and all of that stuff. Then we're going to review 7.1.